In this video, we have two main goals. First, you will learn how to generate the graphs of the three primary trigonometric functions: sine, cosine, and tangent. Second, you will see how these graphs are essential tools for finding multiple solutions to trigonometric equations when the angle is restricted between 0 and 360 degrees. To understand where the sine graph comes from, we start with the unit circle, which is a circle with a radius of 1 centered at the origin. The value of sine x corresponds to the vertical height, or the y-coordinate, of a point moving around the circle. Notice how the graph starts at 0 when the angle is 0. As we reach 90 degrees, the height is at its maximum of 1. At 180 degrees, we are back to a height of 0. As we move into the third quadrant toward 270 degrees, the sine value becomes negative, reaching -1. Finally, at 360 degrees, we complete the circle and return to 0. This creates the characteristic wave shape of the sine curve, which repeats every 360 degrees. Next, let's look at the cosine graph. While sine tracks the vertical height, cosine tracks the horizontal distance, or the x-coordinate, on the unit circle. On the left, we have the unit circle, and on the right our coordinate plane with x from 0 to 360 degrees. Notice that at 0 degrees, the horizontal distance is at its maximum, which is 1. This is why the cosine graph starts at its peak. At 90 degrees, the point is directly above the center, so the horizontal distance is 0. At 180 degrees, the point is at the far left, giving us a value of -1. At 270 degrees, we are back to 0. And at 360 degrees, we return to 1. The cosine graph is actually just the sine graph shifted 90 degrees to the left. It shares the same wave-like properties, oscillating between -1 and 1. The tangent graph is quite different from sine and cosine. Tangent represents the gradient, or slope, of the line from the origin to the point on the circle. When the angle is 0, the line is horizontal, so the gradient is 0. As we approach 90 degrees, the line becomes steeper and steeper, heading toward infinity. At exactly 90 degrees, the line is vertical. The gradient is undefined. This creates a vertical asymptote, which we show as a dashed line. Immediately after 90 degrees, the gradient flips to being very large and negative, then passes through 0 at 180 degrees. The same thing happens at 270 degrees. Another vertical asymptote. Unlike sin and cosine, which repeat every 360, the tangent graph repeats its pattern every 180 degrees. Notice that tangent is not restricted between -1 and 1. It can take any value from -infinity to +infinity. Now that we have the graphs, let's see why they are so useful for solving equations. Suppose you need to solve the equation sine x equals 0.5 for angles between 0 and 360 degrees. If you use your calculator and type in inverse sine of 0.5, it will give you 30 degrees. But is that the only answer? Look at the graph. The horizontal line at y equals 0.5 crosses the sine wave at two distinct points. The first point is at 30 degrees. Because the sine graph is symmetrical, the second point must be the same distance from 180 as the first point was from 0. So, we calculate 180 minus 30, which gives us 150 degrees. Both 30 and 150 are valid solutions within our range. This symmetry is a key pattern for sine. One solution is x, and the other is 180 minus x. In IGCSE exams, you will also encounter equations involving the cosine function. Let's solve one where the value is negative. Cosine x equals -0.7 for x between 0 and 360. When you use your calculator, you get approximately 134.4 degrees. Looking at the graph, we can see the first intersection occurs in the second quadrant, between 90 and 180 degrees. However, the graph clearly shows another intersection point later on. Because the cosine graph is symmetrical about the 180-degree line, we can find the second solution by subtracting our first answer from 360. This gives us 225.6 degrees. So, for cosine, the general rule to find the second solution within the first 360 degrees is to subtract your calculator's answer from 360. Take a moment to look at the graph and see how that symmetry works. Solving tangent equations is often simpler because the pattern repeats exactly every 180 degrees. Let's look at an example. Tangent x equals 1.5 for x between 0 and 360 degrees. Your calculator gives the first solution as 56.3 degrees. Now, look at the graph. Because the tangent function has a period of 180 degrees, the graph looks identical in the next section. To find the second solution, we simply add 180 degrees to our first answer. This gives us 236.3 degrees. If we tried to add another 180, we would get 416.3, which is outside our 0 to 360 range. So for tangent, the rule is easy. Just add or subtract 180 to find other solutions. Sometimes, the IGCSE exam will ask for solutions in exact form rather than decimals. This usually happens when the values involve special triangles. Here are the common exact values for sine, cosine, and tangent for 30, 45, and 60 degrees. Let's solve. Sin x equals negative square root of 3 over 2 for x between 0 and 360 degrees. We start by looking at the graph of y equals sin x from 0 to 360. We know from our table that sine of 60 degrees is positive root 3 over 2. We call this the reference angle. Since our target value is negative, we need the parts of the graph where the wave is below the x-axis. Following the symmetry of the graph, our first solution in the third quadrant is 180 plus our reference angle, which is 240 degrees. And our second solution in the fourth quadrant is 360 to the reference angle, giving us 300 degrees. By using the graph alongside these exact values, you can solve these problems without even touching a calculator. We've now covered how to generate and use the three main trigonometric graphs. To recap, we have sketched the graphs of sine, cosine, and tangent using the unit circle and gradients, and used symmetry and periodicity to solve equations for multiple angles between 0 and 360 degrees. Let's look at the rules. For sine, if you have one solution x, the other is 180 minus x. For cosine, if you have one solution x, the other is 360 minus x. And for tangent, solutions simply repeat every 180 degrees. Whether you are using a calculator or working with exact values like root 3 over 2, always visualize or sketch the graph. It is the most reliable way to ensure you haven't missed a solution or made a mistake with your signs. Practice drawing these waves until they become second nature, and you'll find trigonometric equations much easier to handle.